ladies and gentlemen, welcome to our very first notes of Unit 5. So today we're going to start working with parabolas, and we're going to work on finding the vertex and the y-intercept. So a parabola, actually, if you look at this picture right here, this shape right here is a parabola. So we're going to be learning today how to graph them, and you're going to see parabolas a lot around the world. When you start looking at shapes in nature and all that, parabolas are very popular and commonly seen in nature. So first, let's talk about quadratics in general. We talked a little bit about them in Unit 1. First of all, we know that a quadratic is a degree 2 polynomial, which means it typically has three terms: a squared term, an x term, and a constant. Okay, and it's going to take the general form of ax squared plus bx plus c. When we were going through the quadratics and factoring them, we always talked about our coefficient of a and whether a was equal to 1 or not. Remember that coefficient is always the one with the squared term. And the b coefficient is always the one with the x term. And lastly, the c is always the constant. Well, now we're going to take these quadratics and we're going to actually make them a function. So that means that a quadratic function is simply just y equals ax squared plus bx plus c. So we're going to be using that general form, and we're going to be graphing a lot of different quadratics. So let's talk about these parabolas and what that shape really represents. So the graph of a quadratic is called a parabola, and that's that kind of smiley or frowny face. So there's an example of a parabola, and there's an example of a parabola. So we're working our way towards being able to graph those. So it can be flipped upside down or open up. You can look at it as an umbrella or a bucket. Okay, so the very top or the very bottom is known as the vertex. The a coefficient is going to affect how wide the parabola is, and it's also going to tell us if it's going up or going down. Parabolas are always symmetrical. Remember, symmetrical means that if you cut it in half, it's going to be the same on both sides. Okay, so we're going to actually be using a lot with the fact that it's symmetrical, and we'll be doing that more in our next lesson. Now we want to calculate that axis of symmetry for that line. And the axis of symmetry is going to be calculated by the formula x equals opposite of b over 2a. So that's the formula we're going to be using to calculate that axis of symmetry. Now the axis of symmetry is also the x-coordinate of the vertex. Today we're just going to practice calculating things. It'll make a lot more sense when we actually start graphing them. So let's take a look at our steps. So go ahead and pause the video to write these down. So you want to identify your a, b, and c. That's from that general quadratic form. Then you're going to use that formula x equals opposite of b over 2a. That formula then is going to give you not only the vertical line that is the axis of symmetry, but it's also going to give you the x-coordinate of your vertex. Well, once we have the x-coordinate of our vertex, we also want to know the y-coordinate. So in order to get the y-coordinate, what we're going to do is we're going to take that x, what we got, we're going to plug it back into our original equation, and then we are going to solve for y, get what y equals. Then we have the vertex written as a point xy. Here's another really nice thing. The constant at the end is your y-intercept. Whatever's being added at the end, that's where it's crossing the y-axis. And we're going to take those two things to our next lesson, and we're going to be able to graph parabolas. So today we're just going to practice calculating those things. So what does that look like? Well, first of all, let's take a look at number 1. The best thing to do to start off with is just to assign your a, b, and c value. A is equal to -1, b is equal to 6, c is equal to 4. I know that from that ax squared plus bx plus c formula. Okay, so remember, if there's no coefficient, it's the same as a -1. So I'm looking at this general form. So wherever there's an x squared, that is your a coefficient. Where there's where there's an x, that's your b coefficient. And the thing that's just a number is your c. So once we have that, I first want to calculate the x-coordinate of the vertex. The x-coordinate is going to be like this. So we're going to use that x is equal to the opposite of b over 2a. So now I'm going to plug that in. The opposite of b is -6 over 2 times -1. So I'm going to keep simplifying that out. I get -6 over -2, which gives me a +3. So now I know that my x-coordinate of my vertex is a +3. Next thing I need to do is plug this 3 back in to get what my vertex for my y coordinate is going to be. So wherever I see an x, I have y is equal to. Now wherever I see an x, I'm going to go ahead and put a 3. Be very careful of how you're plugging this into your calculator. I always ask you guys, and I'm going to continue to ask you this lesson, be smarter than your calculator. So many students tell me that numbers squared are negative. That never happens. This is a little different, and it's dependent upon how you enter it in your calculator. What we're saying right here is we're saying we're taking 3, we're squaring it, and we're making it negative. So you really got to watch your order of operations on this. So 3 squared is 9, and then we're making it negative. Plus 6 times 3 is 18, plus 4. So now we're just going to add those all together, and when we add them all together, we're going to get negative 9 plus 18 is going to give us 9, plus 4 is going to give us 13. So we get that our vertex is at 3, 13. So the next thing we need to do is just write down our y-intercept. And the y-intercept comes straight from your c. So your y-intercept is simply your c value. No big deal. Okay, let's take a look at number 2. First, let's assign our a, b, and c value. So our a comes from the square term, and that's 2. Our b comes from the x term, that's 8. And our c comes at the end. Notice that when I do this, I'm taking the signs with. If it's positive, I leave it positive. If it's negative, I make sure I bring a negative down with it. So now I want to use that axis of symmetry equation, the opposite of b over 2a. So I'm going to take the opposite of b, which is negative 8, over 2 times a, which is 2. So we're just going to keep going through and simplifying that out. 2 times 2 is 4. Negative 8 over 4 is negative 2. So now that I know the x coordinate of my vertex, I can plug that back in to get my y coordinate. So I know that y is equal to, now, in this equation, wherever I see a x, I am going to plug in a negative 2. So when I rewrote out this equation right here, wherever I saw an x, I put a negative 2. Now I can go through and simplify. Again, be smarter than your calculator. Negative 2 squared should be positive. Okay, negative 2 squared should be positive. So that gives us a 4 times 2 plus 8 times 2 is negative 16. And then we're going to do a minus 3. So we have 8 minus 16 minus 3. Well, 8 minus 16 is going to give us a negative 8 minus 3. Negative 8 minus 3 is negative 11. I highly suggest breaking it down into little pieces. Then you're less likely to make a calculation error. That is what I see most often with students when they're doing this. Last part is really easy. Okay, our y-intercept is simply just our c term. So we just bring that down. And what we're doing right now, again, is we're calculating those exact things we need in order to figure out what our vertex is and what our y-intercept is. Let's take a look at number 13. Number 3. So first we need to assign our coefficients. So the a term is always with the square term, so the a is 3. The b term is always with the x term, so you get negative 6. And the c term is the constant. So once we have those set out, we want to use this x is equal to the opposite of b over 2a to solve for the axis of symmetry and the x coordinate of the vertex. So the opposite of b, well, negative 6 is going to give us a positive 6. Notice I'm not saying negative b, I'm saying opposite of b. Because if b happens to be a negative number, then it's going to become positive, like we just saw happen here. So then we're going to take 2, and we're going to multiply it by our a, which is a negative 3. So we get 6 over 2 times a negative 3 is negative 6. 6 over negative 6 is negative 1. So the x coordinate of our vertex is negative 1. The next thing I want to do is plug that back into the original equation. Wherever I see an x, I am going to plug in a negative 1. So then I get this. So now I want to go through and simplify it, and this should be squared. So negative 1 squared is just 1. Remember, be smarter than your calculator. So I have negative 3. Negative 6 times negative 1 is going to give me a positive 6. Then I'm going to add 4. So now I just want to simplify these out. 6 plus 4 is 10. And then negative 3 plus 10 is 7. So the y-coordinate of our vertex is 7. So next thing I need to do is know that my C is my y-intercept. So my y-intercept is at 4. So now I've gone through and simplified this problem. I know my vertex, I know my y-intercept. I want you guys to go ahead and pause the video and try number 4. This is tricky stuff. It's okay if you don't understand it completely right now. I want you to at least try it. Last but not least, let's take a look at 5 and 6. So for 5 and 6, we want to first start out by writing out our letters. So our A is equal to 1. Well, we don't have an x term. If we don't have an x term, that means it's not there, which means that the coefficient has to be 0. And our C is negative 6. So this is going to kind of change how we do things a little bit. So we're still going to use that same formula that the axis of symmetry is equal to the opposite of B over 2A. We're still going to put in what we know. The opposite of 0 is just 0. And then we're going to have 2 times 1. Then 0 over 2. Anything, 0 divided by anything is always 0. Okay, so our x, coordinate of our vertex, is 0. So now we're going to plug that back in so we can get our y. Well, 0 squared is just 0. 0 minus 6 is equal to negative 6. So our vertex is at negative 6. You'll notice that is the same as our y-intercept. What happens in these problems is our vertex is our y-intercept. So our y-intercept is at negative 6 because that's our C, but that's also our vertex. And if you don't have a B term, that is what's going to happen. I want you guys to take a second and pause the video and try number 6. And then once you're done, I want you to go ahead and take that quiz at the end of the video.